Saxon Algebra 1, Lesson 106. The sun is shining, the birds are singing, the flowers are blooming, the grass is growing, and we are still doing math. Well, that's pretty special, isn't it? But we're getting there, you guys. We'll be winding down soon, so hang in there and stick with me on Lesson 106. Lesson 106 is a gem. We're going to talk a lot more about it next year in Algebra 2, but John is just getting this information into your brain so it can sit there and kind of smolder over the summer months when you're not actively doing math, but it'll still be in there. And then next fall, when we bring it to the surface again, you're going to be, oh, right, I remember this, and it feels so much clearer now than it did last year. Last year in the spring, it was kind of a blur. So it's okay if this is kind of a blur. Just stick with me. We're going to shove it into your brain, and like I said, it'll culminate, all right? Now, we're going to talk about the equation of a line. This is called, I don't even know what to call it. I don't like John's name for the thing. We're going to call it slope formula. Now, to clarify, so it's about graphing. You can see that, right? Go ahead, groan. It's okay, I don't mind. This is the fancy name, slope-intercept format of a line. Y equals mx plus b, okay? That's considered the equation of a line in slope-intercept format. This is the fancy, specific, technical mathematical language that describes this sentence. Or, yeah, it's a sentence. This, as we know, is how we graph a line. We have a slope that tells whether the line's tipped up or tipped down and how steep or flat it is. It's the little lady in the car with her ponytail bobbing. I hope you know what I'm talking about, otherwise that sounds crazy. This is very specific to our line, and then B is the y-intercept, and that tells us where exactly our line crosses the y-axis. These two very important pieces of information are what give this form of the equation its name, slope-intercept, because it's designed to highlight the slope and the intercept of the line. And we have practiced finding those in several different ways. Today we're going to get a new tool. Today we're going to get something called slope formula. Okay? And that's why I took a moment to review the fancy name for this, because slope formula is not the same thing as the slope-intercept format of a line. I know, it's confusing, but this is a formula we can use to find the slope when we have 2 points. So that's what it's used for. Let me write that down. You know, it would be really great if you guys were taking notes while we did this, and it works really well because you can always pause me and continue copying. You can shut me up and make me wait, which you cannot do in real life. So this is a really great opportunity to practice taking notes because it's got training wheels, right? You don't have to. The most stressful thing about taking notes is trying to write stuff down while the person's still talking and you're like, I can't think. But you don't have that problem in video format. So if you haven't been taking notes, please start taking notes now so that you can learn how to get used to doing that. It's used to find the slope of a line using the slope formula is used to find the slope of a line using 2 points along that line. What does that even mean? I don't even know, and I'm the one who wrote it. I'll explain it to you. Here's the formula. Copy this. Put a big fat puffy cloud around it. This is super useful, you guys. We're going to use it a lot. What this is telling us is that if we have any 2 pairs of points, we'll call them x1 and y1, and x2, y2. Remember, these are subscripts, they're not exponents. They're just like names of two different points. We can take these numbers and subtract and divide, and that will give us the slope. We don't have to count little boxes on a graph or anything kooky like that. This is super useful and it saves you a lot of drama. It gives you a nice, quick, smooth and easy calculation, and so we're gonna practice using it. Example. There are 3 examples in this lesson, just FYI. 106.1, it says, find the equation of the line that passes through the points 4, 2, and -5, -3. Here's the beauty of this, you guys. We do not have to graph this sucker. We could draw out a graph and we could put those points on it. And in fact, John does. Let me show you. John does the heavy lifting for us. He graphs the 2 points, he draws a line, he draws the little boxes so we could count if we wanted to. I don't like counting fiddly little boxes on graphs. So what I prefer to do is calculate, and this is how we're gonna do it. We're gonna take these 2 points. Remember I said we would use 2 points along the line? They're not just random points, they're the points that define this line that we're interested in, just like John showed us in the book. And we're gonna plug these into this equation. Before we do, because this gets really confusing really fast, let me make a few points that will help you keep it simple. It does not matter which pair of points we call the 1 points and which pair of points we call the 2 points. Usually I just keep them in order, but you could call these the 2's and these the 1's if you wanted. It would be fine. The most important thing is that you get the x's in the x place and the y's in the y place, and that the 2 numbers that go together in the same point, they have to be either 2's together or 1's together. You can't mix them up. That would be a mess. So as long as the points within the parentheses have the same notation of either being 1's or 2's, then it doesn't matter which one you call the 1's and which ones you call the 2's. This is what I do. I write x1, y1, x2, y2 underneath so that it's crystal clear what I'm doing, because you'll see when we start to plug it in, we're going backwards and we're doing the y's before the x's. It's very counterintuitive. It's easy to screw this up. So kids, here's a tip. Do this at home. Write it out underneath so that you're totally clear on which one's which. Now we're gonna set up this formula so we can fill it in, and we're gonna bucket it. Please, please use the buckets, because whenever we have minuses in a formula and then minuses in our input numbers, it turns into a headache so fast, and it's much easier to manage if we put the minus signs for the formula here, and then we'll put any minus signs for the individual values into their buckets. Our life is going to be much easier if we do that. Please, trust me. Okay, now we plug in and we go carefully. The first bucket belongs to y2. That's -3. The second bucket belongs to y1. That's +2. x2 is -5, and x1 is 4. Your brain's going in circles. It's not a tough calculation, but just plugging thing in accurately takes a little bit of straight brain. So call on your mammals to help you here. Now we simplify. -3 minus 2 is -5 over -9. And we simplify. 2 negatives cancel. This is the slope of our line. And if you went back to that picture in the book and counted, yeah, it would be rise over run, right? So it would be up 5 and over 9. Okay, that's cool. That's the right answer. But John told us we have to find the equation of the line. So now we've got the slope, but we don't have the y-intercept. Okay, here's what we're gonna do. I'm gonna flip the book and I'm gonna copy this point, 4, 2, and I'm gonna copy this to the top of the next page, right? All right, and then I'm gonna recopy this, the equation of our line, because that's our guiding, that's our North Star, that's our guiding light, you guys. It's everything that we follow. What we can do now, we've got the slope figured out. This is what we need to figure out, right? We need our y-intercept. We've got the slope, and look, we have a pair of points that we can plug in for x and y. So we're going to take this information and we're going to dump it into this format, and we're going to solve for our unknown, which will be b. So here I go. 2 equals 5/9 times 4 plus b. See how I did that? 2 is the y value. 5/9 is m. X is 4. See, I'm just following this format. And then we're solving for that devilish creature. Not really. He's not the devilish creature. This combination is the devilish creature. Okay, now I'm going to subtract 29. So I'm just doing basic algebra here. 20/9. And now I can see 2 needs to be restated as a fraction with 9 on the bottom. So I know that's going to be 18/9, right? And then this cancels. B is all that's left over here. 18/9 minus 29 would be minus 2/9. Okay, so there's the second piece of what we needed. And now what I'm going to do is I'm going to take the first piece I figured out, which was right, and this piece, which PS is also right, and I'm going to write y equals 5/9 x minus 2/9. That's the equation of the line that goes through these 2 points, right? That John drew for us in the book. We didn't even bother graphing it. We don't even care what it looks like. We just know if we have a line that goes through these 2 points, then this is the equation of that line. We used it by 1, using slope formula. And then 2, we plug in x, y, and m to solve for b. Okay, one thing I wanted to mention, back here we were given 2 different values for x and y along our line, right? 4, 2, -5, -3. When we come to this stage, and this is stage 2, right? This is where we are plugging in the values. I just chose one of the pairs of points. That's what you do. You can't use both of them at this step. You just need one of them. We had the options of 4, 2, and what was the other one? I think -5 and -3. Choose whichever one you like. And honestly, this looks way easier to me. It's the positive numbers. They're nice and small. I chose to go with these, but if you use the other ones, what were they, -5 and -3, I think, you would still get the right answer. It doesn't matter which pair of points, just choose whichever one looks cuter. Okay, let's do it again. I know, right? We just dragged through it once, and I'm like, all right, again. Find the equation of the line that passes through 4 minus 2 and -3, 4. Oh, look at the minuses. It's going to be crazy. So I start right away by doing this. Okay, and then I write down my slope formula. Oh, I didn't need that. y2 minus y1 over x2 minus x1. I remember they're not exponents, they're subscripts. Then I create my bucket heaven. Now I go carefully. y2 is 4, y1 is -2, x2 is -3, and x1 is +4. Oh, it's a nightmare. Now we have to be really careful with our rules of addition, right? That becomes a plus. So 4 plus 2 is 6 over -3 minus 4 is -7. So that is our m. I'll just squeeze that in. I put a squiggly to show that I'm not done with the problem, but that was a great pause point, right? I've created something really valuable here. All right, so that was all step 1. We use slope formula to find m. These are my steps. And I think a puffy cloud is called for, don't you? Okay. So now we've done step 1 down here. We use slope formula to find m. Now we plug in x, y, and m to solve for b. So we go back to our points. And we remember we can use either these or these. It doesn't matter. Let's just use these this time instead of just using the first ones. In these, it doesn't matter. The numbers are all pretty simple. There's one minus in each, so whatever. So now we're going with y equals mx plus b, bucket, bucket equals bucket, 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 bucket plus b. We said we're going to use this one. So y is 4. M is minus 6 over 7. Oh, it's a little bucket for a big fractiony number, so I fixed it. Okay, M is minus 6 over 7. X is minus 3. And B is what we're solving for, so we don't know that one. All right, this becomes 4 equals, let's see, that would be positive 18 over 7 plus B. I'm going to write it again up here. I'm running out of space and I don't want to flip my page. 4 equals 18/7 plus B. Okay, so this I have to restate with a 7 on the bottom. So I can, because I know I'm going to have to subtract this, right? So this would be 28 over 7, right? And so then I subtract, that goes away. 28 minus 18. Yeah, that's right. Is 10 over 7 equals B. So there's the second part. So now I'll write my answer up here. Y equals minus 6/7 x plus 10 over 7. Let's see if we got it right. What do you think? Minus 6/7 x plus 10 over 7. Yay, another smiley. Okay, 2 steps. Solve for M, solve for B. Yay, and then rewrite it all smooshed together. Okay, one more. I'm having so much fun, I could just do these all day. Couldn't you? Oh wait, you have the homework to do. You are going to literally do them all day. Sorry. I'm sorry. I'm sorry.